Okay, welcome to another tutorial video. So today we look at one of the questions that is under calculus, additional mathematics, paper 2. It's usually question 11. Now in this question we are tasked, or we are given a curve, negative, this curve is negative 2x to the power 3 plus 3x to the power 2 plus 12 x then plus 27. Okay, now we are told to find the stationary points for this curve or this equation. So what we do when we are finding the stationary points, in some cases they'll ask you to find the coordinates for the same curve. So in this case we are told to find the stationary points, which are the same as the coordinates. So the first thing we do here whenever we are finding this is to differentiate. And you know that when you are differentiating, this power, or the power, the exponent, comes there in front and multiplies with whatever is inside. But there is a rule that this has to be subtracted by 1, and I think that's how we move, and that's how it's supposed to be done. So in this case it means the 3 will come in front here, and then in brackets we'll have the negative 2 there in that order. Another brackets will have the x, then powered to 3 minus 1. Then we get plus, then the 2 in that manner, it will move, multiply with the 3, and this becomes x 2 minus 1 plus. Now this 12, whenever something is like this, it means it is powered to 1. That is the meaning. It means it has got a power 1 there that is invisible, or it has been omitted. So here we assume we have 1, then we've got 12 in there, and then we have x, which is 1 minus 1. Now whenever we are differentiating, once we see a constant number or a number without x, it means that number disappears. So that number will move, and then we'll concentrate here now, we'll multiply 3 by negative 2, we'll have negative 6, and then now we have x to the power 3 minus 1. So 3 minus 1, it is 2, so meaning this will be x powered to 2 plus, in that order, 2 by 3 we have 6, and then x, then we have 2 minus 1 there, it means x will be to the power 1, so it will be left like this, plus 1 multiplied by 12, here we have 12, and then we are saying 1 minus 1, here it is 0. So since this thing is 0, and we know that according to the laws of indices, any number powered to the power 0 is 1. So even this x will disappear as 1 here. So same as when we multiply 1 times 12 times this one, it will still be 12. Hence we have differentiated. And remember, when we are differentiating, we always represent dy dx equal to this number. Now there are two ways here. We can reduce this number if we want, by dividing by 6 or letting it be the way it is. So it's up to you to decide on how you want this thing actually to be. So in this case, maybe let me decide that we reduce it and see how it will be. So we can reduce this, say over 6 over 6 over 6. Then when we cancel there, we'll have negative x to the power 2 plus x plus 2. Okay, so it means that will be our dy dx. So we have differentiated this one. But now we don't end here, because we are looking for the coordinates. So from here you can use quadratic, or you can use factorization by a product. So actually we emphasize that you use factorization by product. So here we'll have our product. We have to look for the product. We need the sum, and we also need the factors. Now in this case, the product we have is -2 because we are multiplying this -1 by 2 here at the end, and then the sum is the middle number, which is 1, +1. The factors, these are two numbers that we are going to look, that when we multiply we get -2, and that when we add we get +1. Now in this case we'll have +2, -1. So these will be our factors. Then now we have to work this thing out. Since we know our factors have been found, so we'll leave this thing here. Now we can move. So we'll get -x to the power 2 plus 2x, we are getting from the factors, minus x plus 2. Then we can factorize from there. The common here is -1, where we have x minus 2 in that order. Even here it is actually -1 in the same order, x minus 2, and that's what we are actually getting. Then now from there now we are saying we've got here what was common is actually x. Okay, here it is x and not -1. It is -x. Moving there, we've got x, yes, minus then this one in that order. So we'll have -x minus 1 closed in that order. We'll also have x minus 2 closed in that order. So as we move, let's just take it down a little bit. We can move this thing up a little bit. Okay, so from there now we are saying this thing is going to be equal to 0. So we'll have now -x minus 1 equal to 0, giving us -x equal to +1, meaning x is equal to -1. That is our first answer, as x is equal to -1. And then the other one is x minus 2 equal to 0. So this will be x is equal to 2. Now we have found x equal to -1 and x equal to 2. Now these are x coordinates that we have found. Okay, x coordinates that we found. Now we need to find we also need to find the what are these? We need to find the stationary points, meaning we need also to find the y coordinates so that we have the complete value that we are looking for. So in this case, we'll go back to our original equation, the equation on top. We'll go back to our original equation, which is the original equation, which is -2x to the power 3 plus 3x squared plus 3x squared plus 12x plus 12x plus 27 plus 12x plus 27. Then we can say y is equal to -2. So here where there is x, we fuse in -1. Everywhere we find that, we fuse in with -1. That's how we move. Plus 12, -1, plus 27. So y is equal to, when you fuse in -1 where there is x, with this you get 20. Once you punch in your calculator, you realize that what you get there is actually 20 as your value. Now we move again to find y when x is 2. So y is equal to -2. Here we punch 2, we put 3 plus 3, we put 2 here, 2 plus 12, everywhere we put 2 plus 27. So when you punch this on your calculator, you get 47 as your answer. Now that you are told or you've been asked to actually find the stationary points. And I said these stationary points are like what? Coordinates. So you can say stationary points, stationary points are 1. We get the first coordinate. The first one was -1, 20, and the second one is 2, 47, meaning this is our answer. So the -1 is representing the x, the 20 is representing the y. So this is for x, this is for y, this is for x, this is for y. That is the meaning. So we have found actually the stationary points that we've been asked to. So now, after finding this, let's go back and read the question once more. These are stationary points we found, but let's understand the question. The question is saying find the stationary points. So those are stationary points, yes, that we have found. Well and good, 4 marks. But the other question is saying determine the nature of the stationary points. Now, when we are determining the nature of the stationary points, we mean we need to find the maximum and also the minimum turning points. That is the meaning. The maximum and the minimum turning points. Now, how do we find this? Because that's how we determine that. Now, let's move. What we do here is that we do a second differential. Yes, there are many ways, but I prefer that you do the second differentiation given by d2y and dx squared like that. Now we're able to see the 2. Okay, 2 there. Okay, let's say x2 equal to, then we get the equation. Remember, this is our equation here, which is this one. But now here we get the equation that has been differentiated, the one which was differentiated at first, and we got the first one as this one. So we get this one which hasn't been actually tempered or reduced. So we can say we have -6x squared. We also had +6, and then the last number was 12. So we need to differentiate this. So how do we differentiate this? This will be 2, -6. We'll also have x powered to 2 minus 1. We'll also have 6. Remember, okay, maybe for the sake of good understanding, we'll put 1 there. I hope you understand where 1 is coming from. And then the 12, as usual, we are differentiating, it will disappear. So let's move. That is d2y over like that. So we move. This and that will be -12 in that order. Then 2 minus 1 is 1. So this will be just x plus 1 times 6, it is 6. Then 1 minus 1 here we have 0. X to the power 0 is 1. 1 times 6, it will remain as 6. So we'll have -12x plus 6 as our answer. Now, to find the nature of the stationary points, we are going to replace this x with the first coordinates that we actually found when we began our solving. So we are going to replace that. Let's move. How do we do it? Okay, good. So the first one, we found that the x value was -1. And the other one, we found that the x value was +2. So we are going to replace this. We're going to say 12, which is -12. Here we get, let's go back to what we are talking about. We have these two values here. X equal to -1, x equal to 2. So we can say here we have x equal to -1 and we've got x equal to 2. This will be the guide. Now that we have those, so we are going to say -12. From that case, we are going to say after differentiating -12, we put the numbers in there. let's begin. So we put -1, then we say plus 6. After that, that will be 12 plus 6. This will be 18. Okay, the first one will be 18, and the second one will be -12. We'll put 2 here plus 6. Okay, -12. There we have -24 plus 6, and this will give us -18. Wow. So these are the 2 points that we're talking about. Now, remember, when you are taught to find the nature of the stationary point, or the nature of the stationary point itself, it's like you've been taught to find the minimum and the maximum turning point. This is what we are actually trying to do. And what we should know is that when y is less than 0, then this becomes your maximum turning point. This becomes your maximum turning point. And when y is greater than 0, this one is the minimum turning point. But now in this case, since they don't want us to find what the maximum minimum turning point is, but that is the same language we are using, we now get these same numbers. We get the -1, comma 18, we close, and we also get now +2, comma 18, and these are the nature of the stationary points. But if we are asked to find the minimum and the maximum, this becomes our maximum turning point. This becomes our minimum turning point, meaning this is the minimum turning point. This is, where is -18? -18 is here, and this becomes our maximum turning point. And that's how you move. So we answer that question. For further questions and clarity, you can contact this number, WhatsApp me, or direct phone call for online lessons and everything on 0975181716. Thank you for watching. Have a lovely day.